Hi, my name is Nikki Lacey. I'm the founder and director of Nichola Wilkin Limited, and I want to tell you about how you can assess your students' programming skills in a surprisingly easy way using a new method I've created called 1, 2, 3. So when we're talking about assessing students' progress in their programming skills, then there are two types of programming skills that they would be doing over the course of a unit. There's the large programming challenges that they might do at the end of a unit, but there's also the smaller tasks that are used for practicing new skills. Now these are just as important. They're the ones that students will be using in every single lesson as opposed to just at the end of the unit or for a large project. So let's ignore those large programming challenges for now and focus on those smaller practice tasks and how we can assess those. Now you may be wondering, do we even need to formally assess these smaller programming tasks? And I think we do. Let's have a look at student engagement over a typical lesson. Now this is just an example lesson, obviously yours might be slightly different. Now they might start off with a group discussion where they're talking about what they think a program might do or some other group or paired discussion that they might be taking part in. So the activity and the engagement is relatively high. And then the teacher might follow this up with some short single answer questions that they might be using. And then they might use a question which has multiple possible answers that students may then be slightly more engaged with. And then this might be followed up with a programming challenge or a task, and just a short task that they would need to do during that lesson. And then this might be followed by some more short single answer questions, followed by maybe a paired discussion, another simple question, and then another programming task, maybe slightly more involved than before. So you can see the engagement has gone up slightly. Again, there might be some more questions, maybe requiring multiple answers, paired discussion, short questions, those sorts of things, and then a larger task near the end of the lesson, and then maybe some follow-up questions from the teacher. So in this lesson, then there's several different levels of student engagement, from fairly basic, where the teacher is just asking a quick question, and higher up where they're actually actively engaged in doing some programming or following a task on the computer. Now for all of those verbal things like the paired discussion and the questions that the teacher might ask the class, then they'd get some immediate feedback from the teacher. They'd say yes, they're right, or that sort of thing, and you might have a further discussion on it. However, with those programming tasks, often there's not really an awful lot of feedback that the student is receiving. They tend to just find out if the program is working or not, and not really any further discussion on it, unless you're taking up an awful lot of time. And that's what I want this video to help you do, is how you can assess those programming challenges. So you might be wondering, why can't I just wait until the end of the term test to really assess their programming mastery skills to see if they've really learned it? And you can do that. You can do a summative assessment at the end of the term, but you really want to do some formative assessments of their programming skills throughout the term as well. And when students are first learning a programming language, it's especially important. They need to get feedback on their coding techniques. They need to identify gaps in their understanding. You also need to be able to catch any misunderstandings early so you can tackle them and they don't get embedded. And students just also want some acknowledgement of their efforts. So there's all very good reasons why you should be giving feedback on those smaller challenges. But the problem is those smaller challenges can have a multitude of things that they're looking at. On the most basic level, you might have programs which are just about sequence, other ones which are about selection or iteration, and then there's a whole jumble of things, and it just gets very messy trying to find one way of assessing all of those different lessons. And you also have the problem of time. When do you actually do this? And you have a balancing act. You can either look at taking up time in the lesson itself. Now the problem with that is if you've got 30 students and you take just a minute on each, then that's half an hour taken up just on giving feedback on people's code. And what do the rest of the students do in that time? It's not really practical to be able to give that individual feedback on their programming technique, not just if the program works or not, but a little bit more detail. Alternatively, you could go in and mark their work after the lesson, and then this adds a whole new load of problems and challenges for you. Either you've got to take time of the lesson to get them to send their programs to you, which is always a little bit of a nightmare, and some will and some won't, or you leave it up to the students, just save them properly, and you go into the area and find them, and that's assuming they've saved them with the right name in the right location or saved them at all. And that can take so much of your own time when you are immensely busy already. So neither of these two are really practical to assess the coding techniques that students have used. So there's got to be a better way. And you're always doing a balancing act about how you're going to actually use your time best. Well, this is why I've come up with a new method, which is what I want to talk to you about today. Now, this is part of my new technique, which is called Jump 1, 2, 3. The jump part is about the pedagogy of how you teach programming in a very effective way, and the 1, 2, 3 part is really about how you can assess those smaller programming tasks, which is what this video is about. So let's just drop jump for now, and we're going to be focusing on 1, 2, 3. So when I started designing this methodology, there were certain things that I wanted it to do. I wanted it to be consistently applicable no matter what type of program those students were creating. I wanted to be able to use the same methodology for assessing them. And so there was some continuity there, and my mark book over time would mean a bit more to me rather than using a different thing for each type of program they were going through. I also wanted it to be quick to implement, so I wasn't wasting hours and hours on marking when there were so many other things to be doing. I needed it to be easy for students to actually understand and get some valuable feedback from that. I also wanted it to be effective at tracking students' progress over time, which is especially important in those early lessons when they need to get some feedback before you can get to the summative assessment later on. So this is what I wanted this method to do, and I also had the problem of time about who's going to be doing this marking, how we're going to fit this into an already busy schedule. Now, one of the breakthroughs I had was I realised that at the moment both of these rely on the teacher doing the marking. But why is that the case? There's other people in the classroom who are perfectly capable of assessing programs, and they are the students. So let them help you with assessing their programs, and this is where peer assessment really comes in, and it saves you so much time. So with peer assessment, it saves you time as it's not relying on the teacher to do all the assessments. You're not taking up that time in the lesson or after the lesson. And it's also a really valuable learning opportunity for those students. They get to see how other programs are constructed for the same program that they've been working on. They can see other options that other people might have come across, or mistakes that they've made, in which case they can know how to avoid those in the future. So it's a really valuable learning tool, and it does save you an awful lot of time. Now, something that this 1, 2, 3 method needs is two things. First of all, you need to have a good idea of the clear focus for the lesson, and secondly, you need to know about the previous knowledge that the students have been taught. Now, this is not new news to any teachers out there. It's something that we already have in our heads when we are planning our lessons. We know what we want the lesson to do, and also what the students have already done previously with us or with another teacher if it's from a previous year. And so there's no extra work in learning about these two things. But let's just see this in practice. So let's use a simple selection lesson as an example. So this would be the first if statement lesson that students would have done. So it's quite early on in their Python programming. And so let's have a look at the focus of the lesson, which would be create a program that displays different outputs based on user input. So that would be the objective of the lesson. So that's the main focus of what we want this lesson to be on. And it's up to you how you write objectives. They can be differentiated or any other technique that you want to use, but we've got an idea of the main focus of the lesson. And then we also need to know about their previous knowledge. Now in my series of lessons, then the previous knowledge that the students would have would be that they would know about input and print before an if statement lesson. They would know how to create user-friendly prompts, and that includes F strings and putting prompts inside the input at this stage. Obviously yours might be in a slightly different order. They would know about creating, naming and using variables, and they would also know how to convert data types, particularly with float and int. So that's what I know that they would be able to do previous to this lesson, or what they should be able to do prior to this lesson, and I also know the focus of the lesson as well. So if we just go back to our timeline in a lesson, then you can see there's lots of different engagement going on. So we've got our paired or group discussions, we've got our simple questions, we've got our multiple answer questions, but we've also got these 3 green points which are the programming activity that they're actually doing. So in this example lesson there might have been 3 times when I've sent them onto their computer to go and do something. However, I don't assess every single programming challenge they do in a lesson. I just need to see if they've met that focus for the lesson. So I need to choose which of those programming challenges or programming tasks that they've done where it would give me the most information about whether they've met that main focus of the lesson. And normally it's the last one of the lesson. Not always though, sometimes we might meet the focus later on and then we look at extending that where it didn't make a clear objective earlier on, but so the main objective was met earlier on in the lesson. But usually it's one of the last programming challenges they've done and they've built up to that at that point. So in this example lesson, then the focus was create a program that displays different outputs based on different inputs, and that would be what they would be able to do by the end of that programming challenge. Now I'm just going to show you the slide that I use in my lesson. Obviously your slides might look slightly different. So this would be the challenge that would be displayed on the board for them. Now this is the 3rd of those sets of challenges that they've got, so each set of challenges might have more than 1 programming challenges in them. So here I've got 3 different challenges. Now this is purely to help those who are quick finishers. So it keeps them occupied, less disruption going on in the classroom. They feel that they're getting something a bit extra. A lot of students who are good at programming like to have a load of challenges. So that's why I've got 3 in there. The first one is the one which is really going to tell me if they've met that focus of the lesson. So create a program that will ask the user to input their exam mark out of 100. If the exam mark is 50 or more, display the message pass, otherwise display fail. So that's a fairly simple if statement, but that meets that objective of using different outputs depending on the input. And this is the important bit that I have to add at the end of that first challenge. After you've completed the program, put your hand up and your teacher will test it works before you move on to the next one. Now that is all I'm doing, is I'm just testing if it works. So I would put in I would go in there, they put their hand up, I would go in there, type in 40, see if it says fail, and then I put in 60 and see if it says pass, and if I'm feeling like it I'll put in 50 because it says 50 or more, just to test that as well. So I'm just doing a very quick test, and if they've passed it I might give them a merit. So that's all I'm doing at that time, is just seeing if the program works, which isn't really enough for them, but that's what we're getting at that time, and that just means I can keep moving around the room, and as students complete the other extension activities then I can award the merits on those as well. I can just test them and award the merits. It means that they're getting a lot of merits. SLT are happy because they're getting all this feedback. Students are happy, there's a bit of a competitive edge going on as well. So you can just use this as the teacher to go and give merit, and you're testing anyway. If it doesn't work, then you say, no, it doesn't work, call me back when you fixed it, and that's all the help that they're getting. So they're being told just to put their hand up and I'll check, because I don't want someone who thinks they've finished the first one then going on to the extension task and actually the first one doesn't work at all. So that's why I want them to check with me before they go on to these extensions. Now some students aren't that fast at the programming, and so you'll find that they might not have finished the program by the end of the allocated time, and we'll talk about that later. But this is for those which actually complete one or more of those tasks. They would just get a merit and that's it. Now the one out of these three that we're actually going to be using this 1, 2, 3 method on is the first one, because that actually checks to see if they've met that focus of the lesson. Don't need to do the others. If they've got that first one working and I've seen that it's working, then I know that they've met the focus of the lesson. If it doesn't work, then they've got to keep on working on that one. So the main program which we're going to be assessing is that first one only. We don't do this on all three, otherwise you'll be there all day. So once I've given them enough time for the class, either people have started finishing all three, those quick finishes, or it's the allocated time that I said, or I just think enough people have really had a good old go at one and you've given them a chance to do it, then I would stop the class and we would go through possible answers. And these are just possible answers, so I would display the answers on there and students know these are just suggested answers. They might have come up with slightly different versions. So they might have used a float rather than int. You can see in question 3 there, I've used the F string as an example there. They might have used concatenation or something else. They might have done if the mark is less than 50, then it's fail, otherwise pass, which is still a working version of that. So they can have variations, and my students are told that those variations are perfectly acceptable and there's nothing wrong with those. Then we need to decide how we're going to assess it. So once I've talked through mainly the first program, because that's the one we're going to be assessing, but I've also touched on 2 and 3, so those quick finishers do get recognition that this is how they could have done it, or the ones that were halfway through program 2 then get to see what the completed one looks like. Then we start on the 1, 2, 3 assessment. So then I would get students to move onto another student's computer so they can peer assess it. And they're looking at just program number 1, not the other 2. So to get the score of 1, we are looking at the code only. They don't run it at this stage. And level 1 is only interested in their previous knowledge that they've already been taught in other lessons. So level 1 is just talking about the previous knowledge. So then I would set some questions for the students to they know how to assess, to look at that previous knowledge. Now there's a whole load of previous knowledge. I want to just choose a few things that we're focusing on. Doesn't need to be everything that they've ever learned. So I'd like to give 2, 3 or maybe 4 questions which are easy yes, no questions that students can answer within a few seconds. So does the program ask the user to input data into the program? So if they used input at some point, then that would be a yes or no answer. Is the data stored as a number? Again, that's a yes, no answer. And have they used suitable prompts to make the program user-friendly? So I could have gone on about print, I could have gone about all sorts of things, but I wanted to just pick a few, and I would vary it. So each time they do this for another program, I would look at different previous knowledge, so I'm not always looking at the same thing all the time. And as you can see, all of these are previous knowledge. They're nothing to do with the focus of the lesson, they are just previous knowledge. Level 2, again looking at the code and not running it yet, this is focusing on the focus of the lesson. So here the questions might be, have they used an if statement with a condition? So I don't just want them to write if, colon, I want if and a condition. Is the condition correct? So then they would need to really think about, is it correct for the type of output that they've chosen? So are they doing greater or equal to 50, or are they doing less than 50, in which case the pass or fail messages might be swapped around. but is the condition correct for the output that they're wanting to produce? And have they used an else statement? So this is the things that I want to focus on from this lesson, because it's a selection lesson. I want to check that they've done an if, that they've done an else, that they've used the right sort of condition. We've already tested to see if they're using suitable output, so I don't need to test what's in that else again, because in level 1 we checked to see if they are giving a suitable output, so that's fine. So all of these are focusing on the main focus of the lesson. Then for level 3, then we are running the code. So this is the first time they get to run the code. And basically, if the program works correctly, then they score the 3. If it doesn't work correctly, then they don't score the 3. So even if there's an error message, they can still get marks for previous working using this technique. So if it produces an error message, they don't get the 3. Even if they've attempted the extension activities, because I told them that they only do the extension activities when I know it's working. We do get some sneaky students who have a go at the extension activities even though that main program's not working. They won't get the mark then if they haven't got that main program working. That's the one we're assessing. So just to recap that, number 1 is if some parts of the code which they should already be familiar with are coded accurately. Number 2 is the main focus of the lesson is coded correctly. And number 3 is the entire program works correctly and is fit for purpose. So let's see how this might work in an example with some students' code. So here again, to remind you, is they want to create a program which asks the user to input the exam mark out of 100. If it is 50 or more, then they pass, otherwise they fail. So this is this student's interpretation of that. So they've got a print statement asking for what they, with a prompt of what they want to do. Then they've got the grade. This time they've used a float, whereas the example I gave was an int with an input in there. Then if the grade is greater or equal to 50, then they've passed, otherwise they failed. Now they've put you have passed and you have failed, that's fine. You don't have to have pass and fail. They've interpreted that, but it's a useful message. So let's see how this works. So going through the questions, does the program ask the user to input data into the program? Yes, it does. There's an input statement in there. Is the data stored as a number? Yes, it's stored as a float. That's fine. And have they used suitable prompts to make the program user-friendly? Yes, they've used a print statement at the beginning, and for the output as well, they've used print statements with something sensible in there. So they've got all 3 of those questions, so they score the 1 mark. Next, we have a look at the 2s. So these are about the focus. So have they used the if statement with a condition? Yes, there is an if statement with a condition in there, so that's correct. Is the condition correct? Well, we need to have a look at it. The grade is over or equal to 50, passed, otherwise failed, so that condition is working correctly. Have they used an else statement? Yes, they have. So those 3 are correct, so they get the 2 mark. And now we run it, and I just need to let you know that this program does work, and so if it works correctly, they get the 3 mark. So this student would score 3, you take the highest mark. Let's have a look at another one. So here they've done a different alternative version. So let's have a look. So does the program ask the user to input data? Yes, there's an input in there, and they put the prompt inside the input this time. So yes, there is an input. Some of you might spot the problem already, but otherwise they have got an input, so that's fine. Is the data stored as a number? Yes, they've stored it as an int. So again, yes, that's fine. And have they used suitable prompts? Yes, they've asked for score, they've said passed or failed, so they're quite brief, but they are user-friendly, they would make sense to a user. So yes, that's fine, I would give them the mark for those. That's 1. Let's have a look at the 2. Have they used an if statement? Well, they've got an if statement there. If grade is greater or equal to 50, so that's fine, so they get that mark. Is the condition correct? Yes, it's greater or equal to 50, and pass or fail the right way round, so that's fine. And have they used an else statement? Yes, they have used an else statement, so they will get 2. and then when they come to run it, then there would be a problem with this because they've missed off the bracket at the end of the line 1. There should be 2 closed brackets. So it wouldn't actually work, it would cause an error message, so they wouldn't score 3. So this student would score 2. Let's have a look at this one. You do get these students who don't really engage with it. They might be messing around or those sort of things. They've done a half-hearted attempt. So let's see how you would score this. So they've done a print statement entering score. They made a start input. They've had a go, but let's see what happens. So does the program ask the user to input data? It does actually ask them to input it. In fact, it's not storing it anywhere. It's not the question. It's asking for an input. So yes, they got that. Is the data stored as a number? No, it's not stored anywhere. It's not given a variable name. It's not told that it's not a string. So no, they've not got that. Have they used suitable prompts? They've used a prompt. The prompt they've used is fine. They've not got anything else there. That's as far as they got. So I would say yes, they got some of them, but because they didn't get all 3 of those right, they've not even scored the 1. So we won't bother checking the rest. So they could score 0 potentially. So let's just have a look again. So level 1 is about their previous knowledge, 2 is the focus of the lesson, and 3 is if the program itself works. Now, just to make this clear, they score the highest score possible. That's what you're going to be recording, is 1, 2 or 3 or 0. It's the highest one possible, but they can only get them if they've got the previous levels in place. So they are reliant on getting the previous levels. So if they've got 1 and 2, they could score 3. If they've only got 1 and they haven't got 2, they can't score 3. So if they don't get the program working, then the highest mark they can get, if they've got 1 and 2 correct, is 2. If they don't get the focus of the lesson right and the program's not working, obviously it's not going to work if they've not got their if statement working, then the highest they can get is a 1. If the previous knowledge is incorrect, but the focus of the work is correct, but the program is not working, they don't score the 2. So even if they've got an if statement written just randomly in the middle of a page without any inputs and prints and things like that, they haven't got 1 working, they don't get 2. They would get a 0 for that because it's nonsensical. So it is reliant on those previous ones, which might seem a bit harsh, but it does allow you to see progress. So once students know the scoring system, they've answered the questions, they've got a score, either 0, hopefully not, 1, 2 or 3 for their colleague, then you can take those marks in and you can store them in something like a spreadsheet very easily, and if you feel like it, add conditional formatting in there as well. Now this is obviously example data, and we've shown that we've had 6 lessons so far, we've got the students there, and so you might end up with this type of thing. And so how do you see progress? Well, we can see that student 4, for instance, they started off not being able to do even the most basic things from previous lessons. Obviously lesson 1 it's tricky, you'd have to just say what the very basics are, but they struggled there, and now they're getting the basics right later on, so that's something to be celebrated. They have made progress. They might not be getting the focus right, but they have made progress. They're learning what they've done from previous lessons, so that is showing progress. This student here is obviously quite good at programming. He normally gets it right most lessons now, so that shows how they are progressing, that they are making progress every week and they are learning a new skill and they're getting that skill right. This student seems to have gone off the boil slightly. So they started off strongly. When it started getting slightly more complex, then they are now making mistakes and missing out on previous knowledge. So it's something that as a teacher you maybe notice that, and so you can hover in the background when they're next doing their programming and have a look at where the problem is. Are they getting distracted because of the seating plan, or is it more the case that they've not understood something from earlier on and they're bringing up a problem, in which case you can jump in and correct that misunderstanding from earlier on. So it does give you a useful tool where you can track progress of students. Hopefully they're going to be increasing, but some students might start off as a 3, but you're still showing that they are learning a new skill, because each lesson is a new skill and they are keeping up with it. So it is showing progress even if they are getting all 3s. So the numbers don't have to go up, they might go down or they might stay the same, but it's showing, because the lessons are getting harder, that they are making progress as they go through. So if we go back to our checklist right from the beginning, we wanted to consistently apply the same marking scheme no matter what the type of program is, and this does allow you to do that because it's looking at previous or current skills. It's quick to mark because you're not doing all the marking, you're getting your students to do the majority of the marking, and then you're taking those grades in and can analyse it later, but someone is looking at their programming, not just the output of the program. It's easy for students to understand. They get the idea of these previous skills, current skills. They have the questions on the board, so they know how to mark it. If there's any disagreements about marks that students got, which does occur occasionally, then you can jump in and say, look, this is the answer to this question. You can use the same criteria and say, this is why you've got just 2 and 3, because you've got an error message there, or it's not actually asking the right thing. And you can also effectively trace students' progress over time. So it is a very effective method. So hopefully that's explained what Jump 1, 2, 3 is about, in particular the 1, 2, 3 part. If you want any more information about Jump 1, 2, 3, then you can visit the website jump123.co.uk. Thank you very much.